Professor Ashim Kumar Raichaudhuri, ex-professor and HOD, Government College of Engineering and Textile Technology, Srirampur, India. Presented in the conference Transforming for Sustainability held in UN City, Copenhagen, Denmark on 28 to 29 November 2018, organized by Roskilde University, Denmark.
My topic is sustainable textile production. Why you should think about sustainable textile? Because you may not be aware of much in Europe, but we are facing. This is the most polluting industry globally, and that's why I switched over from Europe to developing countries. You know, Manchester was the city known for textile. Now there is no textile unit in Manchester. I had been to Belgium, Ghent. There are a lot of spinning units, yarn making unit there. All are closed. So we just switched up to developing countries, China, India, Bangladesh, Pakistan, Vietnam, and so on. And when the industry switched over there, it has increased like anything in last 15, 20 years. So we are facing more and more this pollution problem. This is the most polluting industry in the global. So what is the impact of textile production on the environment? It uses huge energies, huge resources, and then create a lot of waste. And the fashion, it is consumer tempted for new fashion. So every time you change your garment, means new production, and that means a lot of goes to the waste as well as you have to landfill. Textile production consists of these three basic units. That is spinning, that is yarn making, then weaving, cloth making, and third chemical production. First two are energy intensive, we need a lot of energy. But chemical industry processing is polluting. You know about sustainability, I don't have to say about what is sustainability. Now, how we can assess the sustainability of a textile product? As you know, like other product, we have to get the life cycle analysis. So, you for each stage of production, you find out what is the input of material, energy, identify output of the product, and waste generated. And try to have a optimal point for improvement, like eco-efficiency, those are to be calculated. Now, why life of textile and clothing are unsustainable? You are wearing the garment, but I don't know how much pollution it has created. It requires use of toxic chemicals, high water consumption, high energy consumption, huge waste generated, heavy transportation, and use of excessive packaging. Less energy consumption, less pollution. And there are many factors. There are 20 controller factors identified for right first time dyeing. Right first time dyeing means there is no batch correction. One shot, you get the final product. So there is less production. And then finally, it's the waterless dyeing. Water gets all problems in the textile industry. Huge water, huge energy, and then treatment of that water. Now people are coming with this waterless dye where you use this critical point carbon dioxide, super critical carbon dioxide dye. There's a special equipment, special machine. I'm not going in detail. So that gives a complete substitute of water. You use carbon dioxide in a high pressure environment to get the dye. Once you release, carbon dioxide goes to normal. So there is no pollution. But these are at the developing stage. Machines are quite costly. So automation in dyeing and fitting. Earlier, all are manual. If some of our habit of visiting the dyeing units, there are a lot of colors, lot of smells, everything was open. Well, there is lot of automation. This process control with instrumentation. So with process control, there are huge saving in process, energy, what and dye chemical. Then auto dispensing. Automatically, there is a program. You make the program, automatically dye goes to the machine. So there is no wastage of dyeing, weighing and other all this. And then computerized weighting and stuffing. Earlier it's manual weighting, there are a lot of spinning and wastage that can be reduced. And then finally the color measurement. Earlier, people used to go on matching a set. Suppose somebody wanted a set, he used to go on dyeing and dyeing repeated to get the set. But with the computer, now one set it can give the set required. So that gives a faster.
China has some of the worst water pollution in the world. 70% of the country's rivers, lakes, and reservoirs are now classified as polluted, and half of China's water is deemed unsafe for human contact. A major source of this pollution is the thousands of factories that now crowd China's riverbanks, producing clothes and textiles.
We found a wide range of hazardous chemicals in the samples. Amongst these were alkylphenols and perfluorinated chemicals. These chemicals have a range of toxic properties. Both these groups of chemicals are persistent, they don't break down in the environment, and in Europe, alkylphenols are no longer used in manufacturing processes.
Greenpeace also investigated the paper trail of contracts to find out exactly which companies are doing business with these polluting Chinese suppliers. The trail led to a long list of famous multinational brands, including the sportswear giants Nike and Adidas, the Swedish fast fashion retailer H&M, and the Chinese sports brand Li Ning. Many of these brands heavily promote their environmental credentials. However, now the reality is they simply don't.
In a Beijing gallery exhibiting bikini-clad mannequins smothered in dirt, Greenpeace toxic campaigner Zhao Yang delivered findings on an investigation into water pollution from 2 textile towns in China's Guangdong province.
In our investigation on China's water pollution problem, we found that the textile industry is actually a major polluter in China, and so we conducted a further investigation onto 2 textile cluster towns.
The world of fashion has a dirty secret. Companies making our beautiful clothes are leaving a toxic trail, from where they are made to your local mall. But things are changing. More players are joining the movement for a toxic-free future, ensuring our clothes no longer poison our water. This is the story of how people power is changing the fashion world.
We're in Belgium, in a factory specializing in dyeing fabrics. Every year, around 12,000 kilometers of textile materials are dyed here. And for that, millions of liters of water are needed. After use, this water is full of colorants, chemicals and salts. How to recycle this polluted water in an efficient and affordable way so it can be reused in the whole dyeing process? European researchers think they've found an answer to this question.
Over 800 textile dyeing units in Tirupur are an important component in the entire chain in the manufacture of garments. Tirupur, also known as the knitwear capital and as Dollar City, contributes to $2.25 billion and employs over 600,000 people in the textile industry. The discharge of untreated wastewater from the dyeing units into the river Noyal led to the gradual degradation of the river and polluted the groundwater as well. The local farmers petitioned the courts against the pollution caused by the industry, which ordered the industry to implement zero liquid discharge systems or face closure in 2006. The ZLD project was implemented by Tamil Nadu Water Investment Company Limited, TWIC, at a cost of 4,210 million rupees for a combined capacity of 53 MLD for 9 common effluent treatment plants, catering to about 244 dyeing units in the industrial town of Tirupur. Faced with the challenge and lack of technology and experience in ZLD worldwide, the project implementation ran into severe problems, particularly with thermal evaporation of reverse osmosis reject brine, leading to closure of all the dyeing units in Tirupur under the court orders in 2011. Faced with this daunting task under adverse circumstances of court closure and lack of faith on viability of technology for zero liquid discharge, TWIC, in close cooperation with the industry and support of the state government, developed and implemented a unique treated brine reuse technology at an additional cost of 1,500 million rupees for reuse of over 90% of the sodium sulfate salt, along with reuse of 98% of recovered water by a cluster of dyeing units connected to a central wastewater treatment facility.
Sustainable textile production. Professor Ashim Kumar Raichaudhuri, ex-professor and HOD, Government College of Engineering and Textile Technology, Srirampur, India. Presented in the conference Transforming for Sustainability held in UN City, Copenhagen, Denmark on 28 to 29 November 2018, organized by Roskilde University, Denmark. Impact of textile production on the environment. At every stage of the life cycle of textile product, high energy and huge resources are used and large amount of waste is produced. The consumers tempted for new fashion product, the old ones are thrown to landfill or incinerated. The figure shows the energies, resources, waste generation, landfilling and incarnation of textile materials. Water pollution in Indian textile industries. Indian textile industry is second only to agriculture in terms of employment. It employs about 35 million people. Textile represents more than 10% of the country's export. Pollution created by Indian textile industry is very much alarming. On 4th February 2011, Madras High Court ordered to shut down 729 textile dyeing and bleaching units in Tirupur for discharging salt-laden effluent into the nearby Noal River, which has severely affected on local farmers and the environment. However, today 80 to 85% of the dyeing units in Tirupur have effluent treatment plants in place and claim to have achieved zero discharge. But the manufacturers' claim to environmental sustainability is suspect. Residents and farmers have alleged that the dyeing and bleaching units in the city discharge dangerous chemical effluent directly into the river till date under cover of darkness or when it is raining. This is reported in the Wire. Textile City of Tirupur is an environmental dark spot, published on February 12, 2020. Pollution in China. Over the past years, China has become the world's leading producer of textile. This has come at a cost to the environment. China's textile industry produces more than 3 billion tons of wastewater and other pollutant each year. The pollution from the textile industry comes from a variety of sources, including the dyeing and finishing of the fabric, use of harmful chemicals, and the discharge of wastewater. The figure shows a journalist takes a sample of the polluted red water from the Jianhe River in Luoyang, Henan Province, China on December 13, 2011. When environmentalist Ma founded the Beijing-based Institute of Public and Environmental Affairs TPE over a decade ago, many rivers and lakes in China, the world's largest clothes manufacturer, were so polluted that they are effectively dead, he said. Bangladesh pollution. Published by CNN Style, Asian rivers are turning black on 28th September 2020. When Haji Muhammad Abdus Salam looks across the trash-filled river near his home in one of the Dhaka's major garment manufacturing districts, he remembered a time before the factory moved in. When I was young, there was no garment factories here. We used to grow crops and loved to catch different kinds of fish. The atmosphere was very nice, he said, from Savar, just north of Bangladesh capital. The river beside him is now black like an ink stain. Abdus Salam said waste from the nearby garment factories and dye houses has polluted the water. There are no fish now, he said. The water is so polluted that our children and grandchildren cannot have the same experience. The figure shows Abdul Salam and his lake nearby, the dyeing printing industry, and the hazardous condition in front of a factory. In Plastic and the Environment, published by World Economic Forum on 31st January 2020, the fashion industry is unsustainable because the most significant impact fast fashion has on the planet. Clothing production has roughly doubled since the year 2000. While people bought 60% more garment in 2014 than in 2000, they only keep clothes for half a long, that is shorter use. In Europe, fashion companies went from an average offering of 2 collections per year in 2000 to 5 collections in 2011. Some brands offer even more. Zara puts out 24 collections per year, while H&M offers between 12 and 16. A lot of this clothing ends up in the dump. The equivalent of one garbage truck full of clothes is burned or dumped in a landfill every second. In total, about up to 85% of the textile go into the landfill each year. That is enough to fill the Sydney Harbour annually. Harmful effects of textile waste, published in Fibre and Fashion on June 2020 by Aishwarya and Jayashree. Textile waste is produced in every phase of textile manufacturing process, like spinning, weaving, dyeing, finishing, garment manufacturing, and even at the consumer end. The average lifespan of a garment is roughly 3 years. 5% of all global landfill is being taken up by dumped textile waste. On an average, about 15% of fabric used in garment production is cut, discarded and wasted. The fabric that are made from 100% degradable material like cotton, linen, silk, hemp are recycled into a compost or upcycled into a value-added product. Synthetic textile can be upcycled into composites and building blocks to be used in construction or soundproofing applications. Majority of the population has lost the art of mending or repairing of clothes and accessories. Instead, those are thrown out. Industrial textile, it is generated from industrial application of textile, including conveyor belts, filter, geotextile and weaving racks. The reasons for the increase in textile waste. The Western lifestyle is a contributor to landfill waste. The number of items purchased has increased tremendously, mainly due to price drops. Global fast fashion suppliers offer low-priced clothing with a short lifespan. At the end of life stage, textiles sent to landfill instead of reusing the product and forwarding the product for recycling. the production of non-recycled textile fibers for fashion purpose. The dark set of textiles are associated with more dyes and more toxic textile wastewater. Toxic materials like lead, chlorine, formaldehyde are contained into water bodies from the textile industry. No strict government policies in developing and underdeveloped countries. Lack of quality material, if physical durability, comfort, ease of maintenance, aesthetic, etc. are addressed correctly during the design stage, then the clothes often remain useful for a longer duration and even resist fashion change over time. Consumers also lack knowledge on textile care and maintenance. The impact of textile production and waste on the environment. News, European Parliament, updated on 5th June 2013 at 10:19 hours. It is estimated that the global textile and clothing industry used 79 billion cubic meters of water in 2015, while the needs of the European Union's whole economy amounted to 266 billion cubic meters in 2017. To make a single cotton t-shirt, 2,700 liters of fresh water are required, according to estimates, enough to meet one person's drinking need for 2.5 years. The textile sector was the third largest source of water degradation and land use in 2020. In that year, it took on average 9 cubic meters of water, 400 square meters of land and 391 kilograms of raw material to provide clothes and shoes for each European Union citizen. Textile production is estimated to be responsible for about 20% of the global clean water pollution from dyeing and finishing products. Laundering synthetic clothes accounts for 35% of primary microplastic released into the environment. A single laundry load of polyester cloth can discharge 7 lakh microplastic fibers that can end up in the food chain. Microplastics. The majority of microplastics from textile are released during the first few washes. Fast fashion is based on mass production, low prices and high sales volume that promotes many first washes. Washing synthetic product has caused more than 14 million tons of microplastic to accumulate on the bottom of the oceans. In addition to this global problem, the pollution generated by garment production has a devastating impact on the health of local people, animal and ecosystem where the factories are located. Greenhouse gas emission. The fashion industry estimated to be responsible for 10% of global carbon emission, more than international flights and maritime shipping combined. According to the European Environment Agency, textile purchases in the European Union in 2020 generated about 270 kg of CO2 emission per person. That means textile products consumed in the European Union generated greenhouse emission of 120. Existing European Union measures to tackle textile waste. Europeans use nearly 26 kilos of textile and discard about 11 kilos of them every year. Used clothes can be exported outside the European Union but are mostly, about 87%, incinerated or landfill. The new strategies to tackle this issue include developing new business models for clothing rental, designing products in a way that would make reuse and recycling easier, that is circular fashion, convincing consumers to buy clothes of better quality than that last longer, that is slow fashion, and generally steering consumer behavior towards more sustainable options. Under the Waste Directive approved by the Parliament in 2018, European Union countries are obliged to collect textiles separately by 2025. The new Commission strategy also includes measures to tackle the presence of hazardous chemicals producers have to take responsibility for their products along the value chain, including when they become waste, and help consumers to choose sustainable textiles. The European Union has European Union Eco Label that producers respecting ecological criteria can apply to items, ensuring a limited use of harmful substances and reduce water and air pollution. Sources of waste in textile industry: spinning waste, that is during yarn manufacture; weaving waste, that is during cloth manufacture, fabric manufacture; knitting waste, that is during knitting of cloth; dyeing waste, that is created during dyeing of the textile material; clothing waste, that is waste generated during garment and other apparel making process; non-textile solid waste used in production, transportation and housekeeping; and lastly consumer waste, that is waste generated by the consumers. Sustainability means the long-term maintenance of well-being which has environmental, economic and social dimension. Sustainability is assured when the raw material and products are environmental friendly, no harm is done to the environment, the products are ethical, the workers are treated and paid fairly. Life cycle assessment. It is a technique to assess environmental impact associated with all the stages in the life cycle of a product. For each stage, inputs of materials and energy are identified. Output of useful products and waste emissions are assessed. Optimum points for improvement, that is eco-efficiency, can be calculated by the life cycle assessment. The life cycle of textile and clothing are unsustainable because of the following facts: use of toxic chemicals, high consumption of water, high consumption of energy, huge generation of waste, heavy transportation, excessive use of packing materials. High energy consumption. Textile industries are one of the largest sources of greenhouse gases. Energy inputs are coal, electricity, natural gas, etc. However, estimation of carbon dioxide emission is difficult. Textile industries consume high energy with low efficiency. About 4% of the manufacturing energy used in China, less than 2% in the United States. Thermal energy is used for water heating and drying in dyeing and printing. Huge energy, about 35%, is lost during steam generation and distribution. Electrical power, mostly used in spinning, about 41%, and in weaving, about 18%. 20 to 25% energy is used in production, textile production, rest 75 to 80% in laundering by the consumer. So consumer use more energy than production of textile. High consumption and pollution of water. After agriculture, textile is the second highest consumer and polluter of clean water. A pair of jeans required about 1,800 gallons of water. A t-shirt requires 700 gallons water. 20% of the water pollution globally is caused by textile processing in all categories of industrial waste, liquid, solids and gases, as per World Bank report. Textile effluents have a high BOD, bio-oxidation demand, and COD, chemical oxidation demand, total suspended solid, oils and grease, sulfides, sulfates, phosphates, salts of chromium, copper and other heavy metals. That means all sort of pollutions remain in textile effluent. Roots of wastage of water. Excessive use of water in washing, poor housekeeping such as broken or missing valves, unattended leaks through pipes and hoses, continuous drainage of cooling water, inefficient washing equipment, excessive long washing cycles, use of fresh water at every stage. Dye consumption and exhaustion. The global synthetic dyes and pigment market increases from $54.54 billion in 2021 to $60.22 billion in 2020. Now the figure shows the relative consumption of dyes throughout the globe. Figure shows the yellow color maximum consumption is China, followed by USA, shown blue in blue color, rest of Asia in ash color, and Indian consumption is by purple color. The market share about 17% is used in USA and 29% by Western Europe. Now, there are various dye classes are used for dyeing different fibers, and they have different percentage fixation and corresponding loss in the effluent. Remaining is lost in the effluent. Acid dye is used for polyamide. 80 to 95 is fixed and 5 to 20% is lost in effluent. Basic dye is used for acrylic. Exhaustion is very high, 95 to 100. Only 0 to 5% goes to effluent. Direct dye is used for cellulose. 70 to 95% are exhausted. 5 to 30% goes to effluent. Reactive dye is again used on cellulose. 50 to 90% is fixed and 10 to 50% goes into the effluent. Sulfur dye is again used for cellulose. 80 to 90% is fixed and 10 to 40% goes to the effluent. Wet dye is used on cellulose. 80 to 95% is fixed. Remaining 5 to 20% goes to the effluent. Metal complex dyes are used on wool. Exhaustion is very high, 90 to 98%. Loss in effluent is 2 to 10%. Dispersed dyes that is used for polyester, exhaustion again very high, 90 to 100%. Loss in effluent is 0 to 10%. So overall, 10 to 50% of dyes are used in dyeing and printing are discharged in the effluent. Huge residual dyes released in the textile effluent must be treated before release to the outlet. Effluent treatment to give zero discharge, that is, the water coming out of factory after treatment have no pollutant, that is zero, known as zero discharge. ZDHC is a group of apparel and footwear brands and retailers working together to lead the industry towards zero discharge of hazardous chemical, that is ZDHC, by 2020. ZDHC was started in 2011 mostly as a response to the Greenpeace detox campaign. Figure shows the pollutant water coming from the factory at present, and target is the final target is that the water after discharge should have no pollutant. So main challenge is removal of color from the textile effluent. Effluent treatments are carried out in various stages. Most important are filtrations using membrane, then chemical treatment to remove the pollutant, and biological use of toxic dyes and chemicals. Too many dyes are used. About 27,000 dyes are listed under 13,000 generic names in color index produced by SDC UK and AATTC USA. Some aryl amines, that is such as benzidine, are carcinogenic, that is cancer producing, and are under restricted substance list, that is in short form RSL. For example, REACH. REACH is a proposal where some restricted substances are listed. The treated fabric, printed or dyed fabric should not have the restricted substance in a above a very minute level. About 8,000 chemicals are used in textile industry. Many are harmful to human and environment. RSL, that is restricted substance list, contain solvents, pesticides, asbestos, fluorinated compound, greenhouse gases, dioxin and furans, halogen flame retardants, heavy metals, organotin compounds, phthalates and many others. Harmful azo dyes. About 70% of the synthetic dyes contain azo group, that is N-double-bond-N, by reacting aromatic amines and aromatic hydroxy compound. Azo dyes are not available in any substance available in the nature. Under reductive condition, some azo dyes may release carcinogenic amines. European Union Directive 2002/61 by EC identified 21 aromatic amines as harmful and therefore those are banned. Total 187 dyes are banned due to ambient release. Detectable concentration of these amines, carcinoamine, should be less than 30 ppm in the finished article or in the dyed parts thereof. Green chemistry. It aims to reduce the adverse environmental impact of chemical processes and product through life cycle analysis or LCA. It contributes towards sustainable art. There are 12 principles of green chemistry which should be followed for pollution-free textile processing. First, textile or any other processing. First principle, no or little waste. Second, atom economy, that is no waste or byproduct is generated. Third, direct reaction, not stepwise reaction. Fourth, safer reaction. The reaction products are safe. Fifth, catalytic reduction, that is high efficient reactions so that less waste byproduct. Energy efficient processes, renewable raw materials, safer solvent and auxiliaries, safer products, safer byproducts, easy degradable products, and finally 12th principle is hazard control. Green chemistry targets for zero waste. It is measured by E factor. E factor is the ratio of the mass of waste to that of the product. E should be zero for perfect green process. Green and sustainable textile and apparel. Number one, safe for human and physical environment. Made from renewable material, efficient use of resources, that is water and energy during production, decent healthy working conditions, low temperature washing with eco-friendly laundering agents, safe disposal of products to the environment after useful life. These are the conditions mentioned by Textile Institute, UK. Green fibers. Natural fibers are biodegradable, while synthetic fibers are non-biodegradable, but they may be recycled. Cotton fiber is hygienic, but its cultivation is highly polluted. Global cotton production uses 2.4% cultivable fund, using 25% of insecticides and 11% of the pesticides. Organic cotton and organic linen are cultivated without the use of any synthetic fertilizer or pesticides. Organic wool and organic silk are produced in natural and sustainable way. No cruelty is employed during their production. Viscose production uses toxic solvent, but now improved viscose like lyocell uses non-toxic, biodegradable, complete recyclable NMMO solvent made from eucalyptus oil. Biopolymers. Biopolymers are produced by living organisms. They are polymeric biomolecules. Biopolymers or bioplastics obtained from renewable raw materials like corn, sugar, starch, etc. Soybean protein, first produced by Kajita and Japan, and by Boeger, USA in 1930s. Henry Ford believed farms are the factories of the future. On January 13, 1942, Henry Ford patented a soybean car, a plastic car which is 30% lighter than a regular car. Henry Ford came up with a unique tubular steel framework which he could bolt his plastic panels on. It is believed that the plastic was made from soybean, so that the car also called soybean car. Biopolymers are highly biodegradable, biocompatible. Its biomedical applications are wound closure, surgical implant, scaffold, hygiene and protective clothing, soil retention sheet. Examples of biopolymers are bacterial polyester, poly-R3 hydroxy butyrate, bionylon, biopolythene, biopolyurethane, ketone, soybean fiber, alginate fiber. Polylactic acid, it's a sort of polyester. Structure is shown in the figure. It has high strength, good drape, wrinkle and UV light resistance, melting point 170 degrees centigrade. It has reduced flammability, having limiting oxygen index of 25. Greener coloration. One of the method is to use sustainable biodegradable natural dyes obtained from plants, insect, mineral instead of synthetic dyes. Huge amount of common salts are used in coloration. The increased salinity in river upsets the delicate balance of aquatic flora and fauna. The remedies are use no or minimum amount of salt and harmful chemicals in dyeing. Use of low salt reactive dyes. Produce easy degradable dyes. Eco-friendly substitutes of harmful textile chemical. Existing chemical polyvinyl alcohol PVA used as size may be replaced by potato starch or carboxymethyl cellulose, that is CMC. Pentachlorophenol formaldehyde, these are size preservatives, may be replaced by sodium silicofluoride. Carbon tetrachloride CTC is a popular stain remover. It can be substituted with non-ionic detergent, ethoxylates and water mixable solvents like glycol ether mixtures and their mixtures. Enzymatic stain removers. Calcium and sodium hypochlorite. It is used in bleaching, may be substituted with eco-friendly hydrogen peroxide or cold ozone. Sodium silicate, phosphorus compound. These are used as peroxide stabilizer. They may be substituted with nitrogen stabilizers. Alkyl phenol ethoxylate, that is APEO. These are widely used as detergent and emulsifier. They may be substituted with eco-friendly fatty alcohol, ethylene oxide adducts, alkyl polyglycosides. Eco-friendly substitute of harmful textile chemicals. Existing chemical, non-biodegradable synthetic surfactant used for various purposes. They may be substituted with sustainable biodegradable surfactant from dextrine. Dichloro and trichlorobenzene, they are used as carriers in dyeing, may be substituted with eco-friendly butyl benzoate or benzoic acid. Kerosene, this once used widely in pigment printing, now it is no longer used and is substituted with water-based thickeners. Formaldehyde, once used in high quantities in finishing and dye fixing agents, but presently these are substituted with polycarboxylic acid, non-formaldehyde products. Sodium dichromate, it is used as oxidant in dyeing, but now it is substituted with equivalent hydrogen peroxide. Sodium aminosilicones and APO, these are used as softener. They are now substituted with eco-friendly softeners, wax emulsion, etc. Harmful functional finish in finishing, those are substituted with beeswax, aloe vera and vitamin A. Greener preparatory process. A large amount of various hazardous chemicals are used in preparation of textile material before dyeing and printing. They may be substituted with enzyme as it is a green chemical. It is biodegradable, produced with renewable sources, work at lower temperature and atmospheric pressure, favorable, even neutral pH, use less water and energy. It substitutes a number of hazardous chemicals. Process enzyme types. Desizing enzyme used are amylase and lipase. In scouring, enzyme used are pectinase and cellulase. Bleaching, enzymes used are oxyreductase and xylanase. In dyeing, oxyreductase enzyme. Finishing, cellulase, oxyreductase and lipase enzymes. Composting, cellulase, protease, nylonase, polyesterase enzymes. The figure shows how the enzyme works. The substrate have a specific shape on its surface, and the enzyme which is having perfect size so that it fit into the cavity of the substrate, then it is useful. So that's why enzymes are very toxic to substrate, as the enzymes has only the enzyme whose shape matches with the shape in the substrate can lock each other and they can act accordingly. So the working of enzyme is described as lock and key system. Eco-efficient dyeing processes. Some of the eco-efficient dyeing processes are rapid dyeing and low energy processes. In the first case, the small molecular dyes are used so that dyeing is completed in a short time. And in the second case, dyes require low energy for dyeing are used. Then continuous pad batch and pad steam processes. These processes also uses minimum water and production is very fast. Naturally, they are eco-efficient. Use of ultra low liquor ratio dyeing. Some special dyeing has developed having very low ratio. Dyeing is carried out at very low liquor ratio. 20 controllable factors are identified for right first time dyeing or blind dyeing. Right first time dyeing means dyeing in one shot. No correction is required during dyeing. Last and most important achievement is waterless dyeing with supercritical carbon dioxide. At critical point, that is pressure 73.9 bar and temperature 31 degrees centigrade, carbon dioxide adopts properties midway between a gas and a liquid. Carbon dioxide is non-flammable, non-toxic, low price and waste product of combustion, fermentation and ammonia synthesis. So using supercritical carbon dioxide, we can completely substitute water in dye. Greener finishing processes. Some examples are saving of water and energy by low pickup padding processes and minimum application techniques. Next, formaldehyde-free finishes from glyoxal and polycarboxylic acid, that is PCA. Halogen-free hybrid flame retardants. Plasma treatment. Plasma, that is excited partially ionized gas, can interact with polymer surface within milliseconds without hitting the substrate. This polymer treatment can give various surface finishes of textile fabric. Greener effluent treatment. In normal effluent treatment process, coagulant aluminium is used, which can cause Alzheimer's disease. Substitutes of aluminium as coagulant are biosorbent, Sissia angustifolia, CA, seed gum, catagonized cotton, sawdust, coal ash, etc. Hydrogen peroxide and peroxidase enzymes destroys many pollutants, so we can use those. Then enzyme-like catalysts called tetraamido macrocyclic ligand activators, in short it is known as TMLS, are easier, cheaper and much more versatile in their reactivity than natural enzymes. Figure shows structure of TA. Eco labels identify overall environmental preference of a product based on life cycle consideration. There are a large number of eco labels are used in the market. Some of them are developed by government of different countries and others are commercial eco labels. Examples of government eco labels are Blue Angel Germany, Green Seal USA, Ecomark Japan and India, European Flower, European Union, NF Environment by France. Commercial eco labels, some of the examples are Ocotec Standard 100, developed by Austria and Germany, GUT GUT Carpet for carpet industry by Germany, GUW for furnishing fabric developed in Germany, and Global Organic Standard, Textile Standard, GOTS. In this presentation, I have tried to explain the pollutions created in the textile industries in various ways and some of the remedies which are already adopted and some which can adopt in future. I hope you have enjoyed this presentation. Let us work together for a sustainable world by creating pollution at our individual end. Thank you once again.